All right, so welcome back. Today we're going to be looking at solving systems of equations using substitution. So the first thing you're going to be on the lookout for all the problems we're doing this week is to see if you have an equation where one of your variables is isolated. So what you're going to be looking for is if one of your equations is x equals or y equals a bunch of stuff. If one of the variables, like the x or the y, is by themselves to start with, because what we're going to be able to do with this is substitute it in place of the variable in the other equation, that other stuff, which will let us solve for one of our variable. That's what step 2 is telling us. We'll solve for one of our variables by using some of our algebra skills. And then we'll be able to substitute that answer back in to get our second answer. One thing we're going to want to try and do this week is check our solutions. You can do that by plugging them in like we saw last week, or you could also graph these in Desmos and look at the point that they cross and see if it's the same point you got as your answer. One thing is when we get our final answer, we're always going to write it as an ordered pair, x comma y. So let's look at a few examples and we'll see how it goes. So this first problem, you want to look at both equations. You want to see if either of them have the variable by itself. Do you have y equals or do you have x equals? Because that's a good sign that substitution, the method we're looking at this week, is the method you want to choose. So if you look in this first equation, you should see that we have y equals 2x plus 5. Basically, I like to think of this as basically being like a nickname. Y also goes by 2x plus 5. My name's Benjamin. I also go by Ben. If someone calls me Benjamin or Ben, I know they're talking about me. So it's the same thing with y. If you call them y or you call them 2x plus 5, they know you're talking about them. They know you're talking about that first equation. So what we're going to do is we're going to plug this in place of the y in the second equation. So we're going to rewrite that bottom equation, 3x minus y equals 3. But instead of a y, I'm going to plug in this 2x plus 5. So let me color code this actually. So our equation is 3x minus, but instead of a y, we're going to use its other name. We're going to use the 2x plus 5. And then we're going to set it equal to 3. So we just rewrote that equation, but instead of a y, we put this 2x plus 5. We used a second name. The reason why is now this equation, instead of having two variables like x and y, now it just has x's. So we can solve this equation. So we need to do a little bit of our algebra skills. We're going to distribute this minus sign. So that would be minus 2x. That would make that plus 5 a minus 5. This is going to equal 3. Remember, if you have variables on the same side of an equation, you can combine like terms. So 3x minus 2x would be 1x. Then bring down that minus 5. So then to get the x by itself, we could add the 5. So really we get x equals 8. Because 1x is just x, remember. So now we got the first part of our answer. Remember, our answers are going to be x comma y. We got to plug this back in to either one of the original equations, but usually you're going to want to plug it into the one where you had it already isolated, like y equals or x equals. So I'm a little low on space, but we're going to rewrite the y equals 2x plus 5, but instead of writing the x, I'm going to plug in this 8. So 2 times 8 plus 5, and sorry, I know I'm a little low on space, but that would be y equals, that would be 21 if you work that out. So we got our two answers, but just remember when you write your final answer, I'm going to put that over here on the side, but our final answer would be x comma y. So we had 8 comma 21. Okay, let's look at number 2. Same idea. The first thing you want to look for is if one of your equations is by itself. So in this problem, I have x equals y plus 1. So x goes by two names. It goes by x or y plus 1. So we're going to look at the other equation. We're going to, since this is x equals, I'm going to plug that in place of the x. Oops. So if I rewrite that top equation, I'm going to have 2y plus 4 equals 4, but instead of x, I'm going to use its second name. I'm going to use that y plus 1. So now we can kind of solve this using some of our algebra skills. So a lot of times you're going to distribute. Pretty much all of the problems you see, you'll distribute. I mean, you could come up with an example where you don't, but pretty much every problem you're going to have to distribute. So then we want to solve this equation. So like I said, if you have variables on both sides, usually you want to move them to the same side. So usually I get rid of the smaller of the two. So on the left side, we would have 4y minus 2y is 2y. Don't forget that plus 4. You can subtract the 4 over. You would get 0 equals 2y. Anything divided by 0 divided by anything, sorry, is 0. So we know y is 0. So to get our other solution, we're going to plug this all the way back in to that original equation. And like I said, it doesn't matter which equation you plug it into, like whichever one of these starter ones, but usually it's going to be easier 99% of the time to plug it into one that was x equals or y equals to start with. You'll have less, like you'll have less work to do. So we'll just plug in 0 for the y. So it would be 0. We'll plug it into here. So if we work that out, and sorry, I'm running low on space. Let me just erase this so it's out of the way. But we would get x equals 0 plus 1, or that would just be 1. So our final answer, we just want to write these two things we got in an ordered pair. So it's always x comma y, so 1 comma 0. That would be your final answer. If you graph these lines, you would see it crosses at that 0.10. Same with the example 1. If you graphed it, you would see it crosses at 821. But the reason it's important to be able to do this is that you're not always going to be able to graph. You might not have graphing paper, you might not have Desmos, you might not have something like that. And more specifically, if you get a messy answer, like let's say your answer is a decimal, graphing's kind of difficult to see exactly where they cross. I mean, I know Desmos, it's a computer, it'll tell you where they cross, but I mean, if you were doing it by hand, that's going to be a little bit tough. But let's look at a few more. 2 more to be exact. Sorry, I'm going to erase some of this so it's out of the way. I am also going to post a key of like this worked out, so that might be helpful if you miss something if you're trying to follow this video. Example 3 is kind of a weird situation. We have y equals 3x and we have y equals 8 minus x. So they're both in that form we want to look for. So it really doesn't matter which one you use, but usually I just do the first one. So we know y equals 3x. So in the second equation, we can use this nickname. Anywhere I see a y, I can replace it with 3x. So if I rewrite that bottom equation, I'm going to have 3x equals 8 minus x. Oops. And we can just solve that. So, I mean, that's just 3x. So we would add this x. Remember, that's 1x. And there's no number with it. It's just a one of them. That's how many x's are there. So we would have 4x equals 8. So if we divide, we'll get x equals 2. So to get our other answer, we can plug it back in. So I'm going to plug it into this top equation. So that would be 3 times 2, or y equals 6. So don't forget to write your answers in ordered pair. So it would be 2 comma 6. Let's look at one more example. So like I said, you want to look at which equation is already in that form, y equals a number or x equals a number. So that first equation is, and it seems like a lot of them in this have been the first equation, but like if you look at example 2, it was the second equation. So it's not always the first equation you're going to plug into the second equation. Don't get that misconception. But basically y also goes by 3x plus 2. So I can plug that in place of the y in this bottom equation. So I'm going to have 7x minus 8. And then instead of a y, I'm going to plug in 3x plus 2. And it's going to equal 1. So we can kind of solve this like we've seen. We're going to distribute. Just be careful, this minus is going to be distributed with it. If it's basically we're going to distribute a negative 8, but that would be minus 24x minus 16 equals 1. We can combine these like terms because they're on the same side. So it would be negative 17x, 7 minus 24 if you plug that in. Sorry, I got a little sloppy here. This was supposed to be a plus 16. I think the 1 got put inside my plus sign there. So we'll have negative 17x plus 16 equals 1. Actually, and I'm sorry, I just noticed a mistake. I paused the video here. Since this is a negative 8 times positive 2, this should have been a minus 16. So let me fix that. I apologize. So now this is what you should get, negative 17x minus 16. So this I had wrong. So if you were right along, I apologize. But we're going to solve this. So we're going to add 16. You would divide. You'll get x is negative 1. We'll plug that back in to this top equation. So for x, I'm going to put in a negative 1. So that is a little sloppy. Let's try again. So that would be y equals 3 times negative 1 plus 2. So if we work that out, that would be negative 1. So I'm kind of out of space here. I'll just put it below. But our final answer would be negative 1 comma negative 1, x comma y. And in this case, they're the same. So that's a few examples of solvent systems. We're going to be working on it this week. So watch this video. Hopefully it helps.